Hey there guys, and welcome back. So, one thing I'll get to that later. Here is our slidey switch right here. Went ahead and printed it out with the micro switch installed, everything installed, and as you can see, working just fine. Relatively just fine. It's real snappy, which is good. There's the backside. So, a few things to notice. Other thing to notice is other thing to say. Just because we had this concern last night, or I had this concern because I was overthinking things. Obviously, this is tight enough right here that this is not canting backwards because of the rubber band. Again, just me overthinking things, making things more difficult. So, a few things to say about our design. First off, let's start at the top. If I give you a reference plane right here, so here is perpendicular to the wall. Okay, and I don't know if you'll be able to tell. Actually, you probably can. If this is perpendicular to the wall, then you can probably tell that the micro switch is at an angle, and you'll be able to tell that from this side even better because you can compare to the slots. So in theory, the bolts should, if this bolt is at the top of this slot, this bolt should also be at the top of this slot in order for this to be perpendicular to the wall, because that's how we designed the slots, and they aren't. This is at an angle because I found out rather, that this tab was just barely getting stuck on the backside here. Our little flapper tab right here, the lever arm, was so close to this that when we depressed it, it actually was running into the wall and getting stuck. So because I had these slots here, I was able to twist this, and that does mean that we can't obviously adjust this back any further. But it's not at a bad point right now. The actuation is honestly just fine right there. So I'm not going to bother fixing that just yet. I might fix it later on, but that would involve printing a whole entire new unit, and that just seems like we're not getting anything out of it by doing that. However, that is something I should design for in the future. Just make sure that I leave myself, let's say, a millimeter back away from the wall compared to where I expect to put this. Next thing to talk about is down here. You can see how close everything is. Okay, maybe not. There you go. Now you can see how close everything is right down there when this is at the bottom. And therefore I had to get an M12 nut. I pulled an M16 at first, just figuring that'd be more than enough. And the M16 was running into this knurled head down here that we're using for the tensioner. Couple things there. One, I could have swapped the knurl head out for a button head. I didn't, obviously. It's an M4 down here. Honestly, an M4 is probably fine in button head. It's probably not going to strip out. But that is one of those things and just need to watch out for. Is I kept as little space as possible in here, and that means that everything needs to be the exact size. Otherwise, we run up into collisions. Otherwise, this is working surprisingly well. Oh, actually, that is the last thing. The last minor inconvenience here is in order to tension this, right? Obviously, as you can see, this is going to be impossible to even get a... I had Allen key. Oh, there's my Allen keys. You know, even to get a ball-ended Allen key into there is like basically impossible. You know, and by basically I mean literally impossible. So, in order to tension it, I actually have to drag this all the way up. Now, I can go ahead and lock this in here. I can tighten this bolt down and actually lock this part in the upright position if I want to. It's one of these things where when you're tensioning it, you kind of need to keep some tension on this rubber band so it doesn't slide out. Now, as is, it frankly has enough... it has enough friction in the rubber band that it doesn't really want to slide, but that is something we got to watch out for. But otherwise, as I was saying, got to slide this up and then come in from the top to tighten it down. One of those things, I normally have the opposite problem, right? Normally I have the camera on the right hand side, and then you're not seeing what I'm doing from the left on the left hand side. Today it seems like all my problems are left-handed. So anyway, you do this to tighten this down, loosen it up. Actually, this is the other thing that I didn't think was a problem earlier when I was testing this out, but clearly is now that I'm using it more. This, as you can see, is the back part, our retainer back here, is twisting a bit, and I'm assuming that is this guy getting loose up here, and got to get the right sized Allen key for that. So if it's this guy getting loose, which that definitely felt like it, that definitely felt like that was loose right there. What that means is that I probably need to replace this nut with a lock nut to make sure it doesn't get loose. The alternative would have been for this retainer to have a orientation feature relative to this slot, which means that we lose a little bit of travel on the slot if, for example, we extend it out on the top here to make sure that it doesn't pivot. But it's one of those things. Probably the easiest thing is just to get a lock nut so that it doesn't want to twist off. And it's twisting off, I should say, because I'm guessing there's a slight imbalance here on the rubber bands. The rubber bands are not pulling completely straight, and therefore it's twisting it a little bit sideways, and then every time I come in here and readjust this, the screw is not keeping up. So the screw stays in place when I twist this back, and then the rubber band twists it back around, again with the screw staying in place. So that's probably the problem. But yeah, that is everything I have to say about this guy. So we can start talking about the next guy, because obviously I only printed one of these out, and that's because while I was setting this up in the slicer to get it printed, I sat there and I said to myself, man, it's a real shame we can't just push this slider down. And I said, why can't we push it down? I actually could not think of a reason why we couldn't push it down, and why I didn't think of that while we were designing it. And by pushing it down, I mean have a compression spring that runs all the way down here, and then it compresses when it gets pushed up and pushes back down. And that doesn't seem like a terrible idea. Now, frankly, as well as snappy as this rubber band is, I actually really don't mind this design. I would print another one of these just because this, frankly, is real snappy and feels real nice. But it is an interesting idea to have a second one that is based on a compression spring. And therefore, I think that's what we're going to do. The next thing to mention is, so we're going to do that today. So we're going to sidebar on our sidebar. We're going to tangent on our tangent here. And actually make a second version of this that uses a compression spring instead. The next thing I was going to say, this micro switch. So if I put the compression spring up here, it probably still fits. It's probably not that big of a deal. But this micro switch probably we can put down here is what I'm thinking. And then actually put a lever, so attach a lever to the slide that swings to hit the micro switch. So as it comes up, we'll have a pivot point like in the middle, okay? And it swings. Now, I was just thinking having it at the top so that it swings this way backwards towards the micro switch. And the reason I would be doing that is just because it seems a little funny hanging it out here. If it was flat on the ground or something, that would make more sense. But what it's occurring to me is if I put the, let's see, I'm just trying to figure out if there's another way to put that lever arm. And the only reason I'm adding a lever arm here that pivots around is because we're already going back and redesigning this partially anyway. Again, the spring probably can fit right here, so it's probably not that big of a deal. We probably don't need to move the, the micro switch. But it's an interesting idea to have an lever action here, and I'm just trying to figure out whether or not we can't put it on the bottom side. So this tensioner at that point goes away, right? We don't need this tensioner down here, so we have all this extra space down here, and this bolt also is unnecessary. So, I'm wondering whether it's not better to put the lever at the back side though. It changes the angle that is coming down, and we'll see when we get into the design. So anyway, that is all that. That is our intro for today. So let's get to designing. And yeah, all right, I guess I'll clear that out really quick. Read only. Read only. We'll keep that. Mouse bungee number 2 can go away. Get rid of that and get rid of that. Okie dokies, got our documents cleared out. Cool. I have this up because I actually meant to, before the stream, toss a mounting plate in here because I figured that would be useful. Now, let's see, where would I find a plane for this? These are mid planes, that's top, that's bottom, that's front. So we actually don't have one on the outside, it doesn't look like. So I guess I'll come in here and make that. And this is outside of right side if we're assuming that this is the top right here. And then just new component, mounting plate. And this mounting plate is just for reference, basically. Just gives me a good reference for everything. Make sure we're clicking the right plane here because the origin was getting in the way. Project, hole, hole. I want this lever arm too. I'll just take the whole side here. And that's actually the last thing that I am really concerned about. I'm not so concerned with these prongs, frankly. So let's go ahead and do that. Toss these in here. And then just draw the bounding box is all I was looking for. And actually this should not be like that. Now I should put my 2mm on the outside here, actually, because I'm always going to have that as my offset, as my extra plastic around the mounting holes. So since I'm always going to have it, whoops, and actually it would make more sense to do this, wouldn't it? Since I'm always going to have it, I should just include it in this mock mounting plate that I'm doing right here. And that can quinky-dink with that. Alright, there we go. So now I know that this top right corner, and actually I should probably instead, let's finish sketch, go back before this and actuate that. Because again, my problem was in this design that when this actuated, it actually was running into the wall. So I want to go ahead and do that. Where is my joints? There we go. There is that one, drive joint, because I can't see it. -6, I guess. I'm trying to figure out where the most extended point is. 5 really looks like it, but it's hard to tell. I'll call it that. I'll call it 6. Capture position, and then we can come back in here to our sketch, and that should be updated. Cool. And actually, now that this is the high point, I should probably come back in here and change this quinky dink, please. Nope, that was not the right one. Where'd you go? Where'd you go, Mr. Quinkadink? Now it's only showing me 2. Or showing me 1 instead of 2. Ah, there we go. It's over here, that's why. So actually, yeah, I need both the outside ones changed. So that would include this guy. I think it's that guy. There we go. Yep. So these guys need to change. That guy needs to be quinkydink on the furthest point out here. And this guy needs to be quinkydink on the furthest up. Honestly, just 1 millimeter. It's not really a mounting plate. It's just a reference for a mounting plate. So I'll just do 1 millimeter. And that should be enough. Cool. All right. Come back up top. Turn that off so that I don't see it in my actual models. And save. And actually, while I'm in here saving this guy, we can turn this rigid off because I really don't need to see that. And I know the motion link here was broken. I noticed last night. Edit. Animate. Yeah, it's not moving. Wonder if I reverse. No, reverse isn't working. Oh no, it is actually moving. It just doesn't move nearly enough. So my rate is a lot lower. So let's change this to 5 degrees. So that's funny because 5 degrees is what I was getting to get it way over here, but obviously that's not 5 degree. No. Interesting. Obviously that's not keeping up. 10 degrees. One of those things. I guess I'm just going to guess and check until I get something that looks right, looks accurate. 60. 70. Yeah, that looks fine. Okay. And now we can reset this joint before we save. Actually, it's a good thing I didn't save and I stopped there. Not edit. Drive. Put you back to 0. And now. Frankly, we don't need to see that one. I don't think. I think we can just live off of the revolver. Or actually, maybe we turn the revolver off because that's less intuitive and just use that guy. Oh, I see why. Because it only moves from -1. That's why my motion link was silly. So my motion link here, edit feature. This should have been a distance of 1 and 5, I believe is how that would have worked out. -1, animate. Alright, never mind. I'm going to leave it as is. I'm going to stop messing with it. This is funny because I know for a fact that this is editable right now because I changed it. I could have swore I changed it. Whichever. Okie dokies. That is now updated. It is now more or less where it needs to be. So we'll come back in here. Here, you'll see I made a T2. I actually copied this over. I did not drive this. So, and just looking here. Okay, nothing looked like it broke when I updated that sketch. Point being is that there's so much different on here that I decided to just completely come back here and I'm going to roll back and delete a whole bunch of stuff instead of trying to drive 2 different components. So rolling this guy back to somewhere neutral, saving it, and then re-adding all these steps right here. Instead of doing that, I'm going to just go ahead and copy and delete on the other one instead. That is my rationale here. And I do want to go ahead and, before I forget, because I may never come back here, update this so that this is a little further out. And I think I can just change this. Again, it only really has to be like 1 millimeter is probably all I need. I'll do 1.25 millimeters just to get me to an even 15.5. Whoops, that's 1. 15.5, and I don't think this will break it, but let's see what happens. Okay, cool. Did not break it. Good. Yeah, and obviously that's going to be a little misaligned right there, but I'll cry about it. I don't think we did anything serious after this. Whoops. Is the only thing I'm thinking. Micro switch. Where's your origin at? Your origin's way down there. I don't really... actually, I should be able to... I think I can use this as an axis. Oh, actually, it makes more sense to use that as an axis, doesn't it? That makes a lot of sense. Okay. But we're not moving. That is good. Micro switch. Try this again. Micro switch. Micro switch. Please? Why can't I click micro switch? Move components. Modify, move. Micro switch. Alright, there we go. Just being a little bit silly, I guess. Revolve around that corner, and let's get you squared up. Relatively squared up. Again, it's going to be slightly off, probably because I'm doing it by hand. But I guess that's alright. And finish position. Please. Thank you. What was this? Oh, that was another micro switch modification. I don't know why that was. There. Actually, that was pink, right? What is pink? Pink is mounting... No, that can't be mounting plate. What is this down here? Okay, that's the top level. So chances are I dragged or something like that. Is what I did, why that guy was in there. That's probably why that guy was in there. Okay. Alright, yeah, we can just go ahead and leave that guy as is. And go back to destroying the other model. Alright. No coffee left? No coffee left. Alright. Winter time. Alright, time to undo a whole bunch of work over here. And honestly, probably over here... Well, even the tensioner, frankly, is going to go. So, it's probably everything after this point. One thing I realized I didn't do, but turned out alright anyway, is that I didn't set any offsets in here. But because they're dovetails, it's one of those things. They're sliding kind of tangentially to each other anyway, so it didn't really matter. Alright, so we're way the heck back here now. We may want to... Actually, these wings right here don't need to be here either. So wherever we made these, because we are using a spring now. So right there, delete that, and delete the sketch for it. And that block is as tall as it is because... Oh, I deleted the holes in the front. For the record, the holes in the front, they can get a little closer, I found out, than 10 millimeters. I have maybe an extra 3 millimeters worth of space, but probably moving forward, 10 millimeters will be my minimum spacing on the two mounting holes in the front for the extrusion. For anything that uses two mounting holes for the extrusion. Just for the record, because the T-nuts do get pretty close together when they're in the horizontal position to be inserted into the front face here. So, one of those things just for the reference. Alright, now, let's see. It would be interesting to have a rail that this goes on with the spring, but we'd have to add a whole lot of mass to that in order to this design in order to accommodate that. So I think the spring is going to be just fixed at both ends, the compression spring. So if we had the rail would have to come from this point, basically minimum. Whoops, from this point minimum, which is right, it mounted right below the bottom of the slide, all the way up to here, and it has to come out past the nut, because obviously we can't run the slide through the nut. We could actually, alright, we could do 2 compression springs on either side. I wouldn't really want to do one compression spring only, just because that's a bit unbalanced. And one of these things where obviously last night I was concerned for no reason, and with just one spring on the side right here, obviously that would be pushing on this edge, which we want to twist this block. Again, we could throw some features in here to align it, which would be make that less of a problem. We do obviously lose a little bit of slide distance. We can compensate for that though. Let's see. What that does is I don't have to worry about the spring springing out if it gets misaligned. So let me grab a spring really quick, just in case you don't understand what I'm saying by springing out, because I'm using highly technical language right now. Grabbing a spring. Any old spring will do. Just get into my fingers, please. Thank you. There we go. Alright, camera time. Camera time. I can never tell which. So obviously, the spring wants to go in the center position here, you know. But if you have it free floating, you risk it buckling like this and then springing out, is what I was saying. So you can more or less guarantee that won't happen with a shaft running through the middle. So as you can see, it can't spring because the shaft is keeping it in place. Pretend that this shaft is, you know, obviously right there, going all the way through, rather, is what I meant to say. But just fixed at both ends, like I said, you start going, and if it gets a little bit misaligned, it springs. Again, highly technical language, terminology, jargon, etc. Whoops, come back here, spring. Stay. Alright. Hey, you know what? I'm willing to take the risk here. I'm willing to take the risk. So let's go ahead and add these features then. Features to keep the slide aligned. So slider, I'm gonna come off the back side. Yeah, I think I'm gonna do slider first, or the retainer first rather. We'll start here and then we'll build around it on the, actually, will we? I don't think we will actually. I take it back, let's come up here into my initial sketch and add a slot for that. And I'm just adding it instead of changing the distance here, because this is the easier way to do this, to adjust the size right here. More intuitive, I guess, is what I should say. And it looks like that did keep, okay, that only kept that because I was gonna say the hole I was expecting to shift towards center, but that's only because we haven't updated the backside yet. And we can update the backside after we have the hole in, so that's actually not going to be a problem. Now the loft here, I'm actually a bit surprised that's staying, but I opened that up, right? And where's my loft? I was going to say I opened up the second one, I noticed it wasn't constrained, was my point. Oh, okay. Let me project. Okay, so this is on the retainer. So the loft. Oh, we didn't loft. Okay, that's why. That's why I can't find a loft. We just did a combined. Okay, that makes sense. That makes sense. Okay. Anyway, back in here, I'm going to come back to this sketch and grab my reference line right here, which is that guy right there, I believe. And then I can go ahead and make sure that this guy starts out collinear to that guy, and then we'll add again onto that. Which one's the smaller one? That one? Nope, not that one. There and then there. Okay, cool. So that constrains that guy. And then again, I can just come back here and add on to the top here of the retainer. Down, down. Top edge, that guy, and that should be fine. Okie dookies. And I think I'm just gonna do this. Nah, I don't want to do that. I want to make it smaller. Do I? Yeah, I do. Do I? Actually, let's just see what happens. All right, distance to object. There was my plan. And what is the distance from here to here? I think it's only 1.25 inches. I mean, not 1.25 inches, 1.25 millimeters is what 1.5 millimeters rather, I guess. Okay. So it's one of those things. This is not actually putting any pressure on the key right here. It's only putting pressure because it makes contact with the slot itself. So it's not actually that big of a deal. However, alright, so yeah, I'm going to get that cut out then in that case. And again, just keeping things simple with this design, cutting that out. Keep tools. Okay. I do want to offset this face though, to make sure that it does, not that button, to make sure that it fits into these other pieces just fine. So minus 0.05, because I do want it kind of press fit into those sections, but I don't want it, and I don't want it particularly loose. So come back up here, take a look at it. So this will stop this guy from tilting around this axis left and right. That was the whole entire point. We do lose our full 4 millimeters up here, so I'm going to go ahead and come up to the top level and adjust this to be a little bit taller now. And let me see. Okay, Control Z. I want to be here then. Alright, slide length. I guess I'm just going to call 4 millimeters right here instead of defining another variable. Probably a bad idea, but I'll live with my consequences. Alright, there we go. So now we still have the full slide length that we wanted, and we have this keying feature on the slot so that the back retainer does not twist around. Next up is the spring then, and because it's not going to twist around, I am comfortable putting the spring on the side. So, I'm thinking just a 3 millimeter bolt, although I should point out that our slide length right here, which is what, 50 millimeters? Yeah, it's 50 millimeters because it's not width. That doesn't include this part. This part is obviously going to bottom out up here. So, I'm just thinking about the size bolt that I'm going to need. Actually, no, I do need that full 54 because the bolt needs to... does the bolt need to? Okay, so there's a couple things here. One, the spring is going to compress, so the number of turns I have on the spring, the number of coils, times the wire size is how much space I need for it when it's fully compressed at the top here. So let's go ahead and slide this guy up here. We don't have a slide joint just yet, so I'm going to come into frame. Actually, this is going to end up being on the top level on the sustained slide is where it's going to end up putting this, I believe. But that, and then that, and this is going to be a slider along that rail. Okay. And I should define a rigid group in here. Rigid group. I will do child components because I'm not anticipating putting anything else on here at the moment. I will have to change that if that becomes an issue. So, whoops, missed the slider. Let's slide him up So, depending on how I have this attached, and technically speaking, I could attach it to the side of this too. Again, my original idea was to have it up the top here, but so for example, let's just use that really quick as the example. If the spring was at the top here, I would have 5 millimeters of space minus my 3 millimeters, let's say, backstop, piece of plastic retaining the spring. So if I have 3 millimeters retaining the spring, I have 2 millimeters to put a fully compressed spring in. So if my spring is, this is my smaller wire. My smaller wire is millimeters 0.559. We'll call that 0.5 for argument's sake, because the math is easier. So 0.5 millimeters means that I can only have 4 turns. I only have 2 millimeters to work with. Divided by 0.5 diameter is 2 coils compressed against each other to fit in there. So you can see how that's a little bit of a problem, because that 2 coils, when it's fully extended, is not going to have any force at all pushing this down. So, so I said that, and it's one of those things. It's at work. I work with torsion springs, not compression springs. I know torsion springs get weaker the longer you make them. I actually am not 100% clear, and it's one of these things that I should go back over to the handbook and check, or the internet. One of those things. Online calculators are a thing. I probably should figure out that one. I normally just make the spring and say, okay, this feels pretty good. It's how I normally do it. I normally don't bother with math, but I probably should at some point figure that one out for certain. Point being is that we have a limited amount of space. Now, as I was saying, we can actually go 3 millimeters off the back here, and then have our connection point be right there. And that's going at an angle, so let me do the faces instead, because the faces are parallel in theory. So 21 millimeters minus 3 millimeters up here minus 3 millimeters down here for the backstop on this side. Or actually, no, the backstop is going to be all the way down here. It's just, no, that's right, because it needs the guide. It needs a guide going through there. So, point being is that we have a lot more space on the side here, just running it down the side right here. 3 and 3 is 6, so that's 15 millimeters divided by my 0.5 millimeter wire that I was just talking about is 15 divided by 0.5 is 30 coils. So 30 coils is a lot more, obviously. And again, I'm not actually convinced, it occurs to me, that the number of coils determines the force, which is why I stopped myself earlier. Hey, you know what? We have the internet here. We are literally on the internet. Let's do a quick compression spring calculator. Compression spring calculator. I do not want to download an app, no. Select measurements, we'll do millimeters. Inner or outer diameter. Let's see. Do I want to do inner or outer diameter? So, let's just call it 6 on the ID. 6 millimeters on the ID. 6 on the ID. How many of these do I gotta fill in? Because I only know just so much of it. Select end types. End types will be, I guess they're gonna be open. I'm not gonna bother closing them. Or I'm not going to bother grinding them, rather, is what I meant. Load, I don't... come on, I don't... Is there another calculator here that does not take load? Okay, there we go. I don't think this one does. So, my free length would be, let's grab this. I'm going to go here to here. That's my free length. And that's 59 minus my 3 millimeters up here is 56. 56. What is... I actually don't know. Alright, I'm trying a different one really quick. 559. Mean diameter would be ID of 6 millimeters minus OD, which is 0.559 times 2. Calculator, actual calculator on the computer. Actually, let me move this over here for you guys so you guys can see it, what I'm doing right now. That makes more sense. Found a random calculator using random calculator. So anyway, as I was saying, 0.559 times 2 plus 6 is 7, and that is my diameter, right? 7.118. I don't know why you can't just ask me for the ID, because that'd be easier. We got music wire, open ends, and I guess I just throw a random number in here is where I'm at right now. So let's call 20. And do. Let's see. I'm guessing load at solid height is load when totally compressed. I'm assuming that's the terminology here. That 5.75, I don't know what that is though. But actually, the reason I came over here is because I wanted to see what this changes. So we went from 5 to 13 by having half the coils. Yeah. And what else changed here? The rate changed. Oh, it's saying that 10 is not acceptable, right? Yeah, it's saying 10 is not acceptable over here on the stress range, so it has to be more than 10 coils. So 11, 15, 13, 14. All right. I'll try this out. I'll see what happens here. The load again, I don't know if that's in Newton meters or like what in terms of torque, so fun times, fun times. I'll try out this wire. I'll toss this and turn this wire 14 times and we'll see what happens. What if I do closed ends? Calculate. Not good. Okay. Yeah, okay. We'll leave them open. Ookie dookies. Back to our regularly scheduled program. So, we're gonna come in here to slider. I'm gonna, let's revert position really quick because we don't need it up there. And honestly, yeah, I think I'm going to, when we come to the frame here, I think I'm going to use the full 5 millimeters here, 5-ish millimeters here for the base. And we can always countersink the nut in there. Oh, I said this was 50-some millimeters long. I don't know that I have an M3 that long. Let's see. M3, I think the longest I have, it looks like, is 40. I do have them in M4s though, so I guess we're using M4s today. Alright, we're going with M4s then. So, need a bottom of the slider, or actually bottom of the retainer is what I really want here. So we'll come down here. And that, okay, I called that bottom. That probably should be renamed to backside. Or I guess I'm going to call it nut side. Just because it does get a little confusing on that orientation. And I will call this stop side, I guess, is where I'm going to call this. Bottom stop side. Bottom stop, yeah, side of retainer. Okie dookies, I'm going to draw this here, project this out, throw in a 4mm, and leave myself some space for the spring on the outside. Again, the math I just used right there used a mean diameter of 6mm, if I recall correctly. Mean diameter, oh, 7. So 7 was 6 on the ID, I think is what I did, is how I got that. So we probably want to do something like, we can do 10. We'll just go give ourselves plenty of space here. 10mm on the outside, just in case I do not wrap this accurately. Put that tangent to there, put that perpendicular to there, and at the center point. This can be construction lines except for that guy, and then we will, let's see. Actually, if I want that to be 10mm, I probably should turn that solid, and then I'm just going to grab perpendicular here and across is how I'm going to do it today. A little different shape than I normally use, but that's alright. And minus 3mm is what I was saying on that, for that to push off of. So the spring gets compressed against this side right here. And then it's occurring to me, well, we can capture the nut from the bottom, I guess, is the idea. Okay, so let me come in here and do that before I forget. Bodies. Yeah, how do I want to draw this? I guess I'll draw it from this side. Back a frame. Project. Okie dookies, and I already know that is, well, that is what it is. It doesn't necessarily matter. We can ignore it is what I was going to say. So we'll hop in here. This is my platform that will house the nut. And again, this actually this does not look like 5mm. That is 3mm. How thick is a M4? M4 nut is probably more than 3mm. Let us check. Yeah, 3.2. So we may need to, that is exactly 3.2. So the point was that I was going to press the nut in here. So, well, let's take a quick look at it, see if I can't think of a better solution. There and there. And this does not need to be solid. Bodies. Well, I guess the other thing is I could go from the side here and we could work on it from there. So let me turn the extrusion back on. There's the extrusion. And here is my slider. Yeah, I should probably draw this from the side and then just fill this area in, is how I probably should do that. It's a lot of plastic that is unnecessary. So my point was that I was going to do this and then I was going to slide the nut in this way. Actually, I should be able to get, it's a little tight, but I think I might be able to get the nut in On the other side here, nah, maybe not. I'm probably being optimistic, too optimistic. And actually, I didn't check this first. We're lucky that worked out, that 10mm spacing on this side, because this yellow part right here, the tab right here, could be sticking way out the edge. So, actually, we do not need a nut in here. We do not need a nut in here because there's no reason why the bolt should be getting forced up and out. The nut would be used to make sure that the bolt doesn't get kicked out, but I don't think it will anyway. So let's leave the bolt out for right now in that case. And I'm drawing this all the way across. That's really not necessary, so we will go ahead and amend that too. Let's delete this guy and delete this guy. And then I guess I will project the retainer in that case. Project that face right there. That's my hole right there in theory. So we can actually do this. Give myself a 3mm wall in there. 3mm wall over here, and then extrude that. Turn the frame back on. Turn the slider back on. Distance to object. Just keep everything straight. And then I will go ahead and put a hole. Actually, I'll wait. I'll do the top part too. So let me... Where are we going to put this? I guess we just... Yeah, I guess we just put it even with the top part for right now. Is what I'm thinking. Let me slide this guy back up just to visually confirm that that's fine to do. So that is bottomed out right there-ish. You know, might be a hair off, but if I put this right here, I mean, I could actually put it even down here if I wanted to, but let's give ourselves some space. And because it's going to have so much force, well, it's one of those things. Either of these are going to break first. It doesn't necessarily matter. So if I had 5mm, I was going to say I could put 5mm up here of plastic for it to push against. But if I put 5mm of plastic up here, then this is probably going to just be the first thing to break instead. Which is probably better, because I don't want to print the whole entire frame before I print this guy. Now that being said, this is getting printed along this front face, which means that the layer lines are going in this direction. So the torque of the spring could separate the layer lines and blow it out like this in this direction. This guy gets printed face down, so it may do the same exact thing. Really, both of these want to be printed. Yeah, unfortunately, because we have this alignment tab, so the way this wants to be printed is face down like this. That way the layers, the 3D printed layers, are in compression against the spring. That's the stronger part. Unfortunately, we have this protrusion right here, which would be free hanging and therefore require supports. And I don't particularly want to, because it sticks out relatively so far, the angle that I have to bring it down on to make it print without supports, just it seems like a bit of a mess. I might be able to make it work, but it seems like a bit of a mess. So I think we are just going to trust the plastic to hold together and then cry when it breaks. Yep, that I believe is the plan. So let me actually come in here. I can use the same exact sketch for the top part as well. Saves me on a little bit. And we can go ahead and just make this exactly in line with that. And again, I'm just extending it all the way down here for this guy. Finish sketch. Wait, did I not actually extrude the bottom part here? I did not actually extrude the bottom part here. Excellent. Okay. Distance to object. Slider. That side. Okay. And then we can toss the holes in here using the slider. Or using the retainer, rather. Retainer. Sketch. That guy. Not that guy. That guy. There we go. So I can grab this hole right here. And distance all. Not distance all. I don't want to do distance all because that will cut out the front of the frame. So that side. And that's a positive number, right? Yep, that's a positive number. To object that side. Okay. And it looks like that's not actually constrained right there. So let me see what's going on. What about you is not constrained? Oh, we actually never put the 4mm in there. Okie dokies. There we go. And so I only really need to offset this guy right here, give myself some sliding room, and I will give it a generous amount of sliding room. So minus point, let's say 0.2, okay, for it to slide up and down the bolt here. These guys I actually kind of want threaded into the plastic a little bit because, again, I don't want them moving. They shouldn't move, but I want to do whatever I can to make sure they don't. And one of these things, for looks, I kind of want to recess the bolt head. How thick is the bolt head, though? Because that's going to take away my plastic on the top here. Again, I've got the full 5mm going on there, and I lose a full 4mm recessing the head, so frankly I don't think that's worth it. So we are going to leave it. Now on to our next task, and actually before we do our next task, I'm going to go ahead and throw the holes, the mounting holes for the extrusion in here, just so that I don't forget that later on. Projected, and actually I don't need that projection at all. I need the extrusion projection. Turn this frame off. Bodies. Just need this center part right there. That's all I need. Control X, or not even Control X. V. Center line. Actually, I take it back. I do need the frame because I need to know where I'm centering it on the frame. There we go. Draw my circles in. And actually, I normally draw those on a separate line, don't I? And I actually point right there. Okay, here's an interesting idea to do it. So I did this differently last night, as you may recall, but let's do it this way because this way is interesting. So I'm going to put my circles here. These are M4s, is what we use to mount to the extrusion. So there's that, and I said 10mm was my minimum, is that what I'm going for right now? So let's do that. And then we can click that, and then to center it here, center of that to center of that. So that's another way of lining this up, different from how I did it last time. Bodies, and this guy, I will do distance all because I ain't afraid of cutting things I don't want to. So there's that. Now, we need the micro switch, and I said I was going to do the lever arm on the micro switch. I was expecting that to come out the side, which means that I'm going to need it to come out the other side. One of those things, I just naturally put things on the left hand side. Kind of unnecessary for me to say all that, but regardless, let's think about this really quick, right quick. So as this slides up, if we have an arbitrary pivot point right here, Then, let's see. Part of me is already disillusioned with this idea and wants to just move on to other things. But let's try to make it work. Let me take a quick look at my micro switch. Oh, that's one thing I forgot to tell you. Show you, rather. I pulled out 2 micro switches because we're making 2 of these. Here's an interesting one. We're missing the bottom hole right here. As you can see through the top hole, but not the bottom hole. So I got to drill that out. One of those things, no big deal for me because I have, obviously, drill bits. But that'd be awfully annoying if I did not have the drill bits required for that size hole. And I did not have a way of fixing that. Interesting thing. One of those things, I wonder how often that happens at the factory, is basically what I'm getting at. For these 3D, I mean not 3D, these injection molded parts. How often you end up with flashing on that pin and how often they have a problem with that. One of those things, I haven't done injection molding, so I don't really have a reference for it. I'm just interested. So. Now thinking if I put a pin out the side here, if I put a 3D printed pin out the side, use that instead of going from the bottom or anything like that. Come down here. So my biggest problem is that as I swing past the pivot point, it sweeps along the bottom here. And if we start down here, for any given pivot point, we're always moving opposite direction, which means that the limit switch has to be back here, which is a little bit of a problem. For a given pivot, what if I put the pivot way down here? If I put the pivot way down here, well, let me get the extrusion in the picture really quick, just so I have a reference. Pivot way down here. This is going to hit the back side of the extrusion, right? Okay, so if we have the limit switch going sideways parallel with the extrusion, and then it, this angle right here hits this limit switch, we could do that. Okay, so the best way to model that up is the question. I think I'm going to start, even though we're not going to be extruding dead center, I think I'm going to draw from the center though. So let me grab some references here. That. So the interesting thing is that I kind of feel like I got to put a slot in the lever arm so that as it comes up, it slides up and away, because right now the lever arm, if I'm going to hit it against the backside of the extrusion, so as you can see, the distance from here to here is a lot shorter than the distance from here to there, which means that my lever has to change distance from this point, which means that it kind of has to slide up a peg, more or less, is what I'm thinking. So, interesting design problem that I've given myself here. Interesting. It should work, I think. We could also make it Z-shaped, is the other thing we can do. Is another interesting idea. Z or L-shaped. Probably not Z-shaped, just because I'm worried about if the Z is going here right, as it pivots up, as the pivot angle changes, the back side of the Z. So imagine a Z right here. As we go up this slot, actually, imagine a Z down here is what I should start out with. So we've got the Z right here. As you move up, that pivot angle changes right. So now the Z is hitting the back side here. So definitely not a Z, but an L would work because the L would obviously not really pivot enough. And the L would be facing like this so that the leg of the L kicks the limit switch. Whether or not that's necessary is an entirely other question. Oh, I should not have hit Control Z. I actually want to hit that and then go back here and align the limit switch, the micro switch is what I wanted to do. So I knew where it was at, so I had a reference. So honestly, we can put it right up against the ground, I believe, although we do need to have it offset from the what's called in order to get to this pin, from the extrusion to get to this pin if we're laying it on the ground. So let me come up here, try to come up here to that, and we will go ahead and modify, align, micro switch. Where's our mounting plate? Mounting plate, turn it on. So the, let's see. This is what I was thinking. I was thinking here to here. Well, that doesn't even reach the bottom right now. So how about there to there? Oh, and we are not rigidly aligned right now, is an issue. So let's open that up. We'll open that up and fix it. Micro switch, as built joint, body and mounting plate, and that is a rigid. Hit OK, hit the save button, propagate the changes. Save button, close, propagate changes. And now I think we are going to really quick outline, do this, and then where is my color? Where is my color? Why don't I see color here? There it is. I had to open it back up for some reason. It didn't let me do it on the first go. Oh, no. That is not there. Oh, I gotta click the box. That's why. Okie dokies. Let's make it a little bit bolder. Alright. Again, someday we'll get back to the animation program and actually have something a bit more professional. But for the time being, I'm going to BRB really quick. Alright, and I am back, and I just realized I made a little bit of an oopsie there. which I kind of feel like I should have picked up on the audio monitor. Hopefully you didn't notice, but you very well may have. Turn the BRB right off. Is I have an old computer a very old computer that I was running some experiments with, and I left that on for the recording. I meant to turn it off, obviously did not, and unfortunately that means you probably had some fan noises in the background that you don't normally hear. So my bad. Where are we at? There it is. Alright, let's try this again now that you are updated. That to that right there. Alright, there we go. Flip you over, rotate you around, I guess. And then flip you over. And I guess that's actually the wrong side then, in that case. Flip, rotate, flip, rotate. There we go. That's what we're looking for. And then slide you out, modify align that to that, and so in theory I need to flip this guy around. We have a mounting plate on the opposite side of what I want right now, because I want okay, actually no, I think I can get away with this. So I was expecting this lever arm to be on facing the other way, but it's actually probably better that it's heading this way, because that keeps it more square, the micro switch more square overall to the device. So we're actually probably alright with that. Some more water. Here's the question. How far are we from here, and do we want to be further out? We probably don't want to be further out, only because one of those things, I'm trying to leave some space here for the other one to nest out to it. Obviously, if I put the other one on this side, if I put another one on this side, actually two of these may nest with each other just because the pins here might line up. Otherwise, we might have to make the overall size a little bit larger. We'll see what happens. We will cross that bridge when we get there. Okay. So yeah, I think this is where this is going to go. Now I'm going to go ahead and project out from the bottom here a mounting plate to attach this to. And then we will go ahead and... Actually, I will slide you out a bit more because I don't actually want the... Whoops. Capture position, escape, come back. I don't actually want this pin directly up against the extrusion. So... move them out. Yeah, 3mm is fine. Actually, probably more than that. I should probably try that again. Maybe another 3, because I need the plastic to bolt onto this guy. And then I'm probably going to capture the nut in the bottom here, so this is going to be up a little bit higher, just for the record. Again, we'll realign it once we get to that point. So... what are you? You are front face of frame. Okie dokies. And then we can make a new component. Micro switch mount. That was not micro switch mount. That was mountain. There we go. And I am going to put capture position. Actually, not put that there. Let's grab the bottom of the extrusion instead, because that is my absolute floor, regardless of what anything else says. And then I can go ahead and project out the mounting plate here, which is the whole entire point. And then start modifying it from there. So these can be that. Turn you off so I can see what I'm doing. And actually turn the mounting plate off as well because we don't need that anymore. Toss in a bigger plate. Grab the backside of, backside of the extrusion so I know where I'm mounting to. That collinear. This is fine. We can stop there. That is cool. And we can stop there. That is cool. And then we actually can drop in our 2mm right here and come all the way to that tangent. That should have been tangent. Silly. And that's all we really need for that. So I'm going to just toss one more line in here, and this is going to be my wall thickness. And we should be good to... Oh, actually... No, that should be fine. Yeah, because I already moved it out to 3mm that I was going to use for the wall thickness. So yeah, we should be fine. So let us extrude wall thickness here. And that's going to have to go the other direction, and then extrude the back wall from there. Sketch that guy. And how high up do I take you? Distance to object. Let's see. Do I go all the way up? I guess I'll just go all the way up for the heck of it. I don't see any reason not to. This is bottom of extrusion right here. And this is outside of back wall. Grab my holes for that guy. Project that. Okay. Construction lines. You guys know the drill. We've done this a whole bunch. And I'll do it the same way I did the other one to stay consistent. So that is centered.